Do a very, very brief review. I'm going to let you guys work some more on this stuff. So we want to talk about kind of the subtleties here of these compound transformations. So let's look at vertical stuff first. So let's look at this. I want you to tell me what's going to happen with this function here. Now don't just take a second and soak it in. So we're looking at this f of x. And I guess I want to know the order in which I'm doing stuff there. Okay. What do you think? Suggestions. What am I going to do first? Vertical stretch and flip it. Okay. So would you agree that we're starting off with something like, we're going to take a parent graph which goes through 0, 0. Let me zoom in. That's zoomed out pretty far there. So we're taking a parent graph that goes through the points 0, 0, 1, 1, 4, 2, right? It's just a square root graph. Something like that. And we're going to stretch it vertically by a factor of -2, right? Which means I'm flipping it and I'm stretching it vertically by 2. So where does that point go? Stays there, doesn't it? Where does that point go? To the y value is going to go where on that one? But if I'm just doing this, no, that's an outside multiplication, right? So you already told me it's a vertical stretch, right? What I want you to see here is like look at the coordinates of this point. This point, we don't care about the x coordinate, but the y coordinate is 1, right? So that's going to translate, or not, that's going to be stretched. It's going to be dilated down to a point that has what coordinates? If I'm just doing this part, I don't care about the other stuff. I guess that was the point of confusion. Ignore all this other stuff for a second. We're just focusing on the vertical dilation part. -2, right? And how come it's -2? Because 1 times -2 equals -2, right? I'm multiplying that y value. That's what I do when I dilate. I'm multiplying the y coordinates by some dilation factors, right? This is what we would call the vertical dilation factor. And it's a factor, something I'm multiplying, right? So we end up down here with coordinates 1, -2. So then the other, probably the point that we want to maybe use was over 4 up 2. We don't really care about the over 4 part, but we care about the up 2 part. Where's that going to go? So it's going to go to 4, -4. Because I'm going to multiply -2 times -2. So it's going to be right there. Right. Everybody see that? Okay. And once again, we're getting that there because we're starting with +2 times my vertical dilation factor, -2, to get -4. Right?
So if it was -1/2,
So if this was -1/2, then I would be multiplying the vertical coordinates, the y coordinates, by -1/2. So this one would have gone, we would have multiplied 2 by -1/2, and it would have gone to there instead, -1. Okay, and that would have made sense because then that would have been a vertical crunch or squish, right? But we're also reflecting. The negative reflects it. So here's our dilated version, right? That's pretty good, I think. So vertical dilation. Now what comes next? Then what would the other 2 steps be?
translation
Translation, so we're going right 3 and up 1. Okay, good. And what I want you to see here, and this really helps, so we're getting a little more sophisticated with this stuff now. Notice that the x minus 3, I don't have to write them there, but there actually are implied parentheses around that. Everybody agree? Okay. So anytime that we're subtracting something directly from x and from x alone, so in other words, I could replace the x with the quantity x minus 3, right? If I can do that, then that means I'm just doing a straight translation after the fact. After I've done all the warping of the function, then I'm going to do a straight translation, 3 to the right and then 1 up. Okay? And it's not surprising then that this is what our graph looks like, right? We just took this red graph and we dragged it over 3 and up 1. Okay? Make sense? Okay. All right. So let's look at, and those are the points that we get. It makes sense, right? Okay. So now let's look at a different one. Let's look at g of x. So what's going on with that one? Now take a second and think about that. Well, we got to think about it. Yeah, there's something different going on here, isn't there? Right? What do you see that's different? How is g of x different than f of x? Okay, so there are parentheses around the whole thing, right? Right, before. So what's that tell us about the order of operations this time?
You're going to be dilating last.
I'm going to be dilating last, exactly, right? Because what I'm doing is when I multiply -2 times the whole thing, well, this is our function over here, right? This is what we're doing to calculate our y value, right? We're calculating the output of the function, right? Does that make sense? We're going to go through this whole process of subtracting 3 from x and square rooting and adding 1, and that's calculating an output value, a y value, and then we're going to multiply the whole y value, the whole function, right? When we multiply the whole function by something, that's equivalent to multiplying y by something, right? If I multiply y by something directly, then that means I'm going to take whatever I got for my function, and I'm going to take all of the y coordinates and multiply them by -2. So I'm dilating after the fact. I'm not dilating first, I'm dilating after, right? So we'd start off with just the plain, without the -2, just the square root of x minus 3 plus 1, which just looks like that, right? Everybody agree? I have a regular square root function. So if I start at over 3 and up 1, then I'll go 1 to the right and up 1. Regular square root. I'll go from my special point, I'll go to the right by 4 and up 2. All I've done is take a regular square root graph and dilate it, or not dilate it, translate it 3 to the right and 1 up. Right? Everybody agree?
Yeah.
Okay, from there, now I'm going to multiply all of the y values by -2. So that y value, +1, is going to map down to -2. That y value, +2, is going to map to -4, and +3 maps to -6. Everybody see that? So I'm literally going to take this whole thing, and I'm going to stretch the graph as it is, the pre-translated graph. I'm going to stretch it from the y-axis up by 3 and then flip it. So it looks like that. Does everybody agree? Okay, makes sense? Okay. Now, how is that? It doesn't seem like it'd be very different, but how is that different from h of x? What's the difference with h of x? Okay, the negative's on the outside. So what's my order going to be for h of x? What am I doing first on this one?
Dilate.
So first I'm going to dilate by 2, right? Inside the parentheses, look what I've got. So inside, I've got something like that, where I've got a 2 times the square root function. So inside, I'm going to dilate by 2, and then all I did was replace my x with an x minus 3. So after I dilate, I'm going to translate 3 right and 1 up. Everybody agree?
Yeah.
Okay. Then to that finished product, because I've got a negative outside the whole function, I'm gonna multiply all those y values by -1. So I'm just gonna take that finished product and I'm gonna flip it, right? Is that gonna look the same or different than the blue one? It's gonna look different. There it is, right? It is different. Do we see how we get that? Well, one way we could look at that, how about if we were to, right, exactly. So one thing I could do to kind of see this maybe a little better, what if I went up and just changed this one so I make that a +2? Then that's f of x is just what's inside the parentheses in h of x. Am I agree? So there's what h of x would look like, or there's what the part without the reflection would look like, right? All I've done is I've just stretched out this regular one. I've stretched it up by a factor of 2 before I translated, right? That would be, does that make sense? So my regular graph from the special point, instead of going over 1 and up 1, I would have gone over 1 and up 2. Instead of going over 4 and up 2, I went over 4 and up 4. Right, and then to get the vertex there, the special point there, I translated it right 3 and up 1. And now finally, I apply that external, that negative outside the whole thing, right? I'm multiplying y by -1, which takes the red graph and flips it. Okay? Get the idea? Okay? So let's look at same kind of thing. Let's look at one of that guy. Yeah, that one. Okay. So what am I doing with this one? F of x. What's the order there? Left, right? Okay, but what do I have to do first? I have to do a horizontal dilation first, right? Because inside the function, I'm multiplying, remember the x minus 4, I'm just replacing x with x minus 4, right? So that means after I dilate, I'm just going to scoot this thing right by 4 and up by 1. Everybody agree? But first I've got to horizontally dilate by a factor of what? Okay, but I'm horizontally dilating, yeah, by 1/2, right? And it's actually, the negative makes it reflect also. So we could even say that the horizontal dilation factor here is -1/2. So I'm going to multiply all of my original parent function x values by -1/2. Now let's show that. So if we start off with our parent graph again, now what's that look like? So we got a point at 0, 0, we got a point at 1, 1, we got a point at 4, 2, right? And if we just multiply that whole thing by -2, what's that going to do to my coordinates? Well, this one, over 1, up 1, if I'm multiplying by the horizontal dilation factor of -1/2, I'm just going to call it that, HDF equals -1/2, right? Because it's the reciprocal of B. What's that going to do? Where should I expect my new y coordinate to end up? I'm multiplying my y coordinate by my horizontal dilation factor. So I'm going to get -1/2 times 1 is -0.5. So it's going to end up being like right there.
Isn't that different from multiplying by -2?
It is. It is different. But remember that it's different with the horizontal ones. We're actually dividing by that number. We're not multiplying by that number, right? Did I? Oh, sorry. I meant the x, not the y. I have my arrow pointing in the wrong place, don't I? Because this is horizontal. So, okay.
Isn't this just the same as the last question?
It is, but it's similar. It's not the same. We're talking about an inside multiplication, so it's a horizontal dilation instead of a vertical one this time. So we're sliding the beads horizontally instead of vertically like we did last time, right? So we get an x coordinate this time of -1/2, and the y coordinate just stays the same, right? What's this one going to do? Well, the coordinates of this point are over 4 and up 2. So I'm going to multiply, this time I'm going to multiply my x coordinate again by negative 1/2, right? So negative 1/2 times 4 is going to give us negative 2.
Yeah.
So I'm going to be right there. Agree? And you can see what the effect is then. I'm squishing this thing horizontally by a factor of 2, and I'm flipping it over the y-axis, right? Okay, and then all I'd have to do to get to here would just be to take this dilated version of my parent graph and translate it 4 right and 1 up, and we should see that. Okay, everybody agree? Okay. So, what about questions on that? Okay, so far so good? Okay, how is this one different? What's my order of events happening there?
You're flipping the weight here. Right.
Yeah, so what am I doing first here? Okay. What's the dilation maybe? 'Cause maybe you're right. Huh. See the difference? Now look, see the difference here is that 2 is being multiplied by the quantity x minus 4. So it's like saying 2x, but I'm just replacing the x with an x minus 4. That's not what's happening here, is it? Right? Here I've got 2 times x, but it's the minus 4 is separate from the 2x. Right? Okay, so this is a different situation. This is equivalent to, on the last example we did, when we multiplied the whole thing in parentheses, that was the equivalent of multiplying y by something, right? Multiplying the vertical variable. Now we're multiplying the horizontal variable, which is x, by 2. So we have to do that last, right? Just like we did with the y's. Remember on that last example, let me go back for just a second here. I think it's that one. No, it's not. It's that one. Remember what we did here, right? We had to do all this stuff first, and then the finished product, that's all my output. That's y. I multiplied y by negative 2 last, right? Same thing I'm doing here. Same thing I'm doing here, right? I'm multiplying, I've got to do all this stuff first, and then I'm going to multiply just the x by negative 2. So when all is said and done, I'm going to horizontally dilate the finished product by a factor of negative 2, right? So I'm going to start off by just taking a regular graph, square root graph, and going right 4 and up 1. Okay, so what's that look like? We're doing the, oh, sorry, this one. Yeah, never mind. Sorry, we'll do this one. So first of all, we have to rotate, but we're still saying the same thing. We've got to go right 4 and up 1, and then we're going to dilate that whole thing by a factor of 2. Actually, I screwed that up, didn't I? That's outside, so what do I have to do first? I have to reflect first, right? Reflect first, then I move it right 4, up 1, and then the last thing I do is I multiply the variable x by 2, which means I'm going to take the finished product and I'm going to horizontally dilate by a factor of 2. Yes, sir?
So if it's inside the radical, you do reverse, like what you do if it's outside the radical?
So we'll, by it, you mean the negative?
Last time we did the outside of the parentheses last, and then this time
Right, okay, but the reason we did the outside of parentheses last was because the parentheses were around the whole function. So that's equivalent to like multiplying y, which is the whole thing, by something. Right, you see what I'm saying? Like these parentheses here, these are the same kinds of parentheses we had in the first one. This is a replacement. I'm replacing x with x minus 4, right? That's a translation. This is different, right? Here we've got this negative in G is like the negative 2 was in F. right? The way that I look at these, and this might be helpful, is if I'm multiplying the x by 2, just the x by 2, not the quantity x minus 4, I would just not even worry about the 2. I would just, it's invisible for a while. You're going to do you have to do that last. So we're going to start off dealing with just that function right there, right? Negative x minus 4. The square root of negative x minus 4 plus 1. Get that whole thing done, and then we got to stretch the whole thing horizontally by 2. So let's do that part, right? What if we take this f of x and we change it so it just looks like that, right? Isn't that the same as g of x, except we've got a 2 in front of the x in g of x? So everybody agrees that's not a very hard one though, is it? Right? That just looks like that, doesn't it? Right? Think what we're doing. We're going to take our regular parent function and we're going to flip it horizontally, and then we're going to take the flipped version and we're going to scoot it over 4 up, or over 4 to the right and up 1. Isn't this red one just the shape of just a horizontally flipped square root graph? Instead of going over 1 and up 1, we're going back 1 and up 1. Instead of going over 4 and up 2, we go back 4 and up 2, right? But we just translated the flipped square root graph 4 right and up 1. Now look at the impact though of multiplying this by 2. If I put in at these points, let's graph these points. So here's a point at here's a point at 0, 3. Here's a point at 3, 2. Here's a point at 4, 1. So what's going to be the impact then of multiplying this thing, the x, by 2? What am I going to do? The last step. Yeah, I'm going to take that graph and I'm going to horizontally dilate everything by, what's my horizontal dilation factor going to be though? If I multiply inside by 2, what's that mean I'm actually horizontally dilating by? Dividing by 2, so it's 1/2, right? So this means my horizontal dilation factor is 1/2. So what do you predict for me then? What's the x coordinate of my blue graph going to be? Here. Same. What about this one? The x coordinate? 1.5. So I'm going to multiply the horizontal component, x, by 1/2, right? So it's going to be right there. What's this one going to be? 2. It's going to be right there, right? See it? Okay. So last one then. How is this one different? No parentheses. So the negative is with the 2. It's the negative 2 that's being multiplied by x at the end, right? So we'll just ignore that, right? So once again, we'll go back to our regular, well, this one isn't flipped though, is it? All right, so we're okay with the second one? I'm going to erase this, okay? So let's do this. Let's make this one positive. So everybody agree with that? Well, that's going to be hard. I'm going to have to shrink that a little bit.
Where's the magnet parentheses around the negative 2x?
Yeah. Right, so this is, yeah, we don't, right, so that's this guy down here without the negative 2 in front of the x, agreed? And we have to apply, the negative 2 is being multiplied by x, so that has to come last. So let's make some predictions. What are going to be, here are my coordinates. I've got coordinates of that point are 4, 1. This point is 5, 2. This point is 8, 6. So what's going to be the impact this time of doing this? What's my horizontal dilation factor that time? Negative 1/2. So that's what I'm multiplying the x coordinates by, right? So what's this x coordinate going to map to? -2? So we're going to slide it horizontally out to -2. What about this one? -2.5, so that's going to be about right there. Because we're going by, it looks like that's -3. And then this one's going to be right there, right? Agreed? What do you know? Okay. There's a lot going on there, right? I don't teach all this stuff every year. This is pretty sophisticated. And it's, you know, you can't really think about this stuff, but I'm doing it for you guys. You guys can handle this. Okay? All right? Go. Your work, get questions answered. Okay? I could wait.
Could you request me today?
I can. You betcha.
Can you request me today?
Yep.
And
Can do.
also, like, I have any after school tests
I've got practice after school. Yeah.
before school.
I tell you what, I gotta do TAs before school. I've got so many preps and basketball stuff going on. I really can't until basketball season's over. I probably won't be able to do either one, but I can do
When's like basketball season?
end of February. Yeah, I'm kind of stuck. I know you're kind of.
I need tests assignments. I've done a lot of them, and I just need to get the tests.
That's fine. We can do that during TA. Yeah, and I'm willing to give you time. That's fine.
Those will be
Yeah, they will. I agree. So if you get the assignments done, I'll just get you in every day for a while in TA and we'll get them done in there. Yeah.
Could you delete one of my attempts?
Yeah,
On
you
that
bet.
test, like the current one, because I just want to start fresh. It's kind of a waste of time.